This lesson is on section 7.3, using similar triangles. If the two triangles are similar, then they have two characteristics. The first characteristic is the corresponding sides, the sides that match up, have to have the same ratio, or they have to be proportional. The second characteristic is that their corresponding angles, the angles that match up, have to be the same measurement. There are three postulates and theorems that prove that our two triangles would be similar. They work very similar to the 5 postulates and theorems that we used in order to prove that two triangles were congruent. The 3 postulates and theorems are the angle-angle similarity postulate, and that just says that between the two triangles, if you know that 2 pairs of angles in one triangle are congruent to 2 angles in another triangle, then those two triangles have to be similar. Their sides have to have the same ratios, and all of their angles will be congruent. The second one is the side-angle-side similarity theorem. And that one says that if you know of one angle in each of the triangles that is congruent, and the sides that are included on either side of that angle have the same proportion, then the triangles are similar. So you would check to see if the ratio of one pair of sides is the same as the ratio of the other pair of sides, and then the angle in between them would have to be congruent. The third one is the side-side-side similarity theorem. That one says if all 3 pairs of sides are proportional, then the triangles are going to be similar. We use these rules, so to speak, to find measurements in triangles that are missing. We call this indirect measurement. We use indirect measurement a lot in order to find the lengths of things that we can't normally find the length of. For example, the distance across a pond, or how tall a flagpole is, or whether or not the tree is so tall that if it falls down it will hit a house. Those are the kinds of things that we use this type of measurement and these types of rules to show. The first type of question that you're going to see in your homework, or that you need to be able to answer, is, do you know that these two triangles are similar, yes or no? And so we would go back, and our 3 options are the angle-angle similarity postulate, side-angle-side similarity, or side-side-side similarity. This one will probably be a little bit more obvious than some of the others, but notice that we don't know any pairs of sides, nor do we have any congruent tick marks to say that any pairs of sides are congruent, are similar, so we can automatically take those 2 out. So our final question is, do we know 2 angles in each triangle that are congruent to each other? Well, the arcs tell us we have 1 pair of angles that are congruent, and we can use the knowledge that we already have to find a second pair of angles that are congruent. The second pair of angles that would be congruent would be the vertical angles here. These 2, since they're vertical angles, are always congruent. Therefore, the angle-angle similarity postulate works because we have 2 pairs of angles in each triangle that are congruent. Therefore, the triangles must be similar. Another kind of problem asking these same types of questions. Notice we have pairs of sides here that might be proportional. If you look at 3/8 and 4/6, those are not the same ratio. 3/8 does not equal 4/6. However, if we look at it a different way, 3/6 is the same ratio as 4/8. Both of them have a ratio of 1/2. So we do have 2 pairs of sides that are proportional. Okay? If we have 2 pairs of sides, the only thing we need then is the angle in between those 2 sides. If we know that the angles in between those 2 sides are congruent, then our triangles are similar using the side-angle-side theorem. Do we know that this angle is congruent to this angle? It's the included angle between the 2 sides. And the answer is yes. They are vertical angles, therefore they are congruent to each other, therefore the side-angle-side similarity theorem works. These two triangles are similar. A couple of example type problems that you're going to see. For example, this one, wanting to know the length from here to here. This might be a pond that you are trying to find the distance across that you can't just measure. What you can do is on the dry land, you can measure out pieces that you know and then use those pieces to set up a proportion. We know that this side is corresponding to this side. So the ratio of 36 over 65 would have to be the same as the ratio of of 40 over x. Okay? So you can cross multiply and set up this is the proportion, and you would cross multiply to solve. You would take 36 times x and get 36x on one side of the equal sign, and then you would take 65 times 40, and that would give you 2600 on the other side. From there, we simply divide by 36, and our side length, or the distance across our pond, would be 72.2. We don't have units labeled. It might be feet, it might be meters, it might be anything. Okay? But that's how you do it. You find this side corresponds to this side, so you set up that ratio in the same as you set up the pair that you already know. Since I put little triangle over big triangle on one side of the equal sign, I have to put little triangle over big triangle on the other side of the equal sign. Cross multiply and divide. The answer is 72.2 units, whatever they may be. Sometimes your similar triangles do not sit apart from each other. Sometimes one sits directly inside the other. If you notice, this smaller triangle is going to be similar to this bigger triangle. The reason that we know that they are similar is because the angle postulate, this angle in the little triangle is exactly the same as that same angle in the big triangle. And since these lines are parallel, this angle is going to be congruent to this angle. So we know that the triangles are going to be similar. The question is, how are you going to set up the proportion to find the missing value? In the little triangle, the left-hand side is x and the bottom is 60. So we can use x over 60. Little triangle, left side over bottom. On the other side, we have to do left side over bottom. The bottom is 80, but I know a lot of you would want to put the left side is 32. That is not the left side of the bigger triangle. That is only this part of the bigger triangle. To represent the whole left side, just like we did up here, the whole left side of the small triangle was x. The whole left side of the big triangle would be x plus 32. At that point, it becomes just a cross multiplication again. We cross multiply, and we take 80 times x is 80x, and then we're going to take 60 times more than one thing. So 60 times x is 60x, and 60 times 32 is 1920. It becomes an algebra problem. We minus our 60x over to this side, and we've got 20x equals 1920. And then we divide by 20, and x is 96. The distance here, from here to here, would have to be 96. That concludes this lesson. Your homework, according to your classes, is as follows.